What's going on, math people? We are back, and this time we are talking about the mean value theorem. Alright, so check this out, right? The mean value theorem says, suppose you have a function that is continuous on a closed interval. Continuous on a closed interval. So we have boom, and then we're going to change over to the green to get us a function. Waba. Alright, and endpoint, boom, closed interval. Alright, that function is continuous on a closed interval from A to B. And it says, and it's differentiable on the interval interior points of A and B. Alright, so then there is at least one point C in AB at which the slope right here, f of b minus f of a over b minus a, is equal to the calculus version of slope, f prime at c. So that's saying there's some c, where the slope is the same as the. So here's another thing about mean value theorem. I thought this was real interesting. Things you need to know about the mean value theorem, right, is this right here. Check this out. When I saw this, I was like, oh, I'm trying to drop off an image on this thing for y'all. This right here, it was solid, yo. Geometrically, the mean value theorem says that somewhere between A and B, all right, that's the curve has at least one tangent parallel to the chord AB. So, look at this. I guess that would be fuchsia, or however you say that color. Slope, F prime of C. So what the mean value theorem is saying is parallel lines have the same slope. So if you got a tangent line and you have a chord that's parallel to that tangent line, then the slope of the tangent line equals the slope of the chord. Let's do an example. All right, so an example says, let's say we have let's say we want to find out what C will produce what C is needed to identify the equivalent slope. So let's say we have f of x is equal to simple equation x squared on the interval on the closed interval from 0 to 5. All right. So first thing you do, applying the mean value theorem, find the slope from the algebra standpoint. So we have f of 5 is equal to 25. F of 0 equals 0. Now calculating the slope, you're changing the y values over the change in the x values. And that gives us 5. All right, so that's from the algebra standpoint. From the calculus standpoint, we're going to input C for x. So we have f of C. Let's get a different color. Let's pull out that black. F of C equals x squared. F prime of C, I'm sorry, that should say C squared, not x squared, equals 2C. Now, whenever we set these equal to each other, according to the mean value theorem, we can find out what that value of c is that will produce the slope at that tangent location. So that x value of c would equal, say we have 5 equal to 2c. So c would equal 5 halves, or 2.5. And that's the mean value theorem in a nutshell. So basically all that says is, on the closed interval of 0 to 5, here's 0, here's 5, the graph is looking something like this. Alright. That is, f of 5 gave us 25. And f of 0 gave us 0. And it says here that the c that is parallel to the tangent, that produces the tangent that's parallel to this chord AB here. So we have this chord. That's supposed to be a straight line, don't judge me. The c that produces this is 2.5. And it would be right about there. So if we was to draw the tangent line, it will look something like that. Mean value theorem in a nutshell. You're welcome.